Okay, so for today's Khan Academy assignments, there are 3 different assignments, and I'm going to give you a little bit of help for all 3. So the first one is eyeballing the line of best fit. So first of all, eyeballing is the technical term for, no, just kidding. Eyeballing means look at the different lines and pick the one that looks like the line of best fit. So this part should be pretty easy. So for example, if I come and look at this right here, here are my points. It looks like a positive relationship. So clearly the green line, line C, fits the data pretty well, right? Got a few points on this side, a few points on this side of it. So if I get this one, I would select C. But remember, we have the option that it could be that none of the lines fit the data. So there's the first one. So now if I go out of that, what else did Miss Kaiser pick for us to do? This one. So this one's more involved. So what does it say? Estimating equations of lines of best fit. So let's stop there for a minute. So I'm going to have lines of best fit. There's my lines of best fit. And each one of them has an equation attached to it. Remember, it's going to be in the form of y equals mx plus b, where m is whatever number is in front of x. That's our slope. And b is our starting value or initial value. So b is wherever this line crosses the y-intercept. This one would be down here somewhere. Okay, so after we estimate the equation, then we will use that to make predictions. So what is a prediction? So it's kind of like a hypothesis. In this case, you get to be pretty technical with it because you take the data and the line of best fit, and then you get to predict something. You get to decide what something might be. So let's look at this example right here. The percent of adults who smoke recorded every few years since 1967. So there that is on my y-axis. Sorry, my x-axis. Right here's the x-axis. Suggests a negative linear association. So I see negative slope here. It looks like linear with no outliers. So an outlier would mean I'd have some random point up here, some random point down here, or some random point somewhere. That would be an outlier. But this has no outliers, so it's a pretty strong trend here. And it says a line was fit to the data to model the relationship. So when they say a line was fit to the data, that's the same thing as this. It's just the line of best fit. Same thing. So, first question, which of these linear equations best describes the given model? So again, if I look, all of my answer choices are in the form of y equals mx plus b. So I need to know what my slope is and what my y-intercept is. Slope y-intercept, slope y-intercept, slope y-intercept, to pick the one that matches. So it's negative slope. So I already know it's got to be one of these that has negative slope. And it crosses the y-axis at positive 40. So that's my initial value. So it could be one of these that I see here. So let me look and see. There's year 20. There's year 10. So it looks like my change in y going up when I go from 30 to 35, that's 5 years. And that is my rise divided by my run is 10 years. So 5 divided by 10 is 1/2 or 0.5, but it's negative. So this would be my answer choice here because I've got the slope of negative 0.5. That's my slope in front of the x. And then my y-intercept was at positive 40. Now, then they could ask me, based on this equation, so taking the equation, so I have to get that right first. Based on this equation, estimate what percent of adults smoked in 1997. Okay. So I could just look back up at my graph too for this one. Okay. In 1997, so this says years since 67. So 1997 would be at 30 years past 67. So at 30, I come up on the line here, and it looks like when X is 30, Y is 25. So it'll be 25% of adults smoked in 1997. So I would use that. Okay. Then the final exercise for Khan Academy for today would be interpreting slope and y-intercept for linear models. Okay. So these are linear models. I have scatter plots, I have a line of best fit, and it's asking me to interpret. So I've got to figure out something about it. Okay. And looks like they're all asking me about slope if I look through here, all of these that I see. So I'm going to pick the one about potato chips because it's potato chips. Panel of judges was asked to judge the quality of different types of potato chips. We have a scatter plot and a regression line. So that's that same thing as the line of best fit, and it shows the relationship between ratings and price. Okay? And it tells us that this fitted line has a slope of 5. So remember, slope is rise over run. So now let me come and look at my graph. So rise is average rating, right? That's my Y. And the run is my cost. So I have to do rise first and cost underneath. So if the slope is 5, that means 5 rating points divided by $1, right? Because I have to do y-axis first. It doesn't mean $5 for 1 rating point. 5 is 5 over 1, so the average rating every time I go up 5, I'd go over 1. Okay, and it looks like C would be my answer here. Nope, this would be my answer. Why? Because only $1 in cost for every 5-point increase in rating. So you see, that's why you got to read carefully. I saw that 5 over 1, but I had to read carefully because the dollar amount is what goes on the bottom and that 5 goes on top. And we know that this doesn't make sense because they didn't have any ratings of -5. And this says the chips that cost 0, the chips that are free, have a rating of 5. And if I look here, the chips that are free would be down here somewhere, right? Not a rating of 5. So if the slope is 5, then I need 5 over 1. And that's how you do that. But obviously you will have to look very carefully at these, read carefully to pick the right one.